Hello, my name is Nathan Crozier, and this is my presentation on binary. Binary has been around for a long time, since 1679 in fact. The modern binary system was credited to Gottfried Leibniz. It is based on the Chinese figures Fu and Z, which was his inspiration for using only ones and zeros. He noted that these figures were the reason that China had accomplished so much mathematically. So what is binary? Binary is a very efficient way of putting as much information as possible into a condensed format that is easy to read and simple to perform operations with. Binary is most affiliated with a computer's processor. Binary is currently the fastest way for a computer to process information and perform complex calculations and is the standard for today's computers. Each one in binary represents the state on, while the zeros represent the state off. Interestingly enough, any given number has a binary representation. Two-set binary uses the powers of 2 to represent each place value. Typically, it goes as such: 0, 2, 4, 8, 16, 32, 64, 124, and so on. This is because we use the exponents 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. To create a binary digit, we multiply ones and zeros by these numbers. For example, to create the number 150, we would write 1, 0, 0, 1, 1, 0, 1, 0. This adds up to 124 plus 16 plus 8 plus 2, which then adds up to 140 plus 10, which finally brings us to 150. This can be done using any number, even numbers greater than 200. If all the places are taken up by a 1, you can then add a new place value with a number that is greater than the last. Although typically we use a total of 8 places separated with a space in the middle, so 150 would actually be written like this. Binary can also be used to write every letter in the English alphabet in both lowercase and uppercase. To do this, we assign an integer to every letter in the alphabet. For example, an uppercase A is represented by the number 65. Therefore, to write the letter A in binary, we would write 01000001. That would calculate as 1 times 64 plus 1 times 1, which equals 65. People have taken to writing whole messages in binary and using it as a secret code to stop curious onlookers. The computer can also interpret this as letters as long as you specify that as a string and not an integer. To write the word binary, we would have to write the numerical value for each letter. This would be 66 for B, 105 for I, 109 for N, 97 for A, 114 for R, and 121 for Y, which would then be written as so. There is actually a pattern one can notice here while reading binary to help let them know if this is simply numbers or if it is actually a string. Capital letters are always written with 0, 1, 0, 0 at the start, while lowercase letters are always written with 0, 1, 1, 0. So if one were to look at a portion of code and notice that the groups start with 0, 1, 0, 0, and then are followed by multiple pieces of 0, 1, 1, 0, then you can deduce that it's probably a word. To conclude, binary is a very important notation that is strong in use today and underlies the majority of modern computers. It creates a very simplistic way of condensing vast amounts of information into simple little strings of code that a computer can then utilize to maximize its efficiency. After all, a computer is best at doing simple things very fast over and over again. Binary allows it to do just that and only that. While binary is not necessarily the most revolutionary method of representing values, it is nonetheless extremely important in today's society. Without it, we would not have computers as fast as we do today. And due to us relying on these devices for the majority of our days, it makes a big difference. Today, we always want our technology faster, and this largely contributes to exactly that.